welcome to my talk. I will talk about this nice topic here, UI redressing attacks on Android devices revisited. As maybe some of you already know, I have given this talk in the Abu Dhabi Black Hat conference at the end of 2012, and at this time it will be a new version. And for this reason, we can find the revisited term inside the title. So I will show you some new attack techniques, so a zero day, which is totally new, and at the end, we will see that we can hack or pwn every Android phone which is available at the moment. By the way, who of you has an Android phone? Please raise your hands up. Okay, and the rest iPhones? Okay. So Symbian user, no here. Okay. Then who am I? Why did I talk about, or why do I talk about this topic? Well, I'm from the Horst Goerz Institute of IT Security, which is in Germany. It's a part of the Ruhr University in Bochum. And there I'm doing my PhD. I'm doing some research stuff regarding cross-site scripting, clickjacking, or rather UI redressing, and more or less the OWASP top 10. Besides that, I'm the CEO of a new company, which is Freecurity. The reason is that I am giving security trainings and penetration tests in the fields of web application security, especially for the OWASP things, since the last maybe 10 years. And for the reason that I really love UI redressing next to my girlfriend is that the result is that I have wrote a book about it in German, which is called Clickjacking und UI Redressing, und is and in German. And it is maybe 200 pages long and contains a lot of things, a lot of attack techniques. So if you're able to read a book in German, have a look. I'm also a speaker at some conferences. I think it was were 30 in the last 2 years. Among them, the Black Hat conference in Abu Dhabi, the Blue Hat, which is the one from Microsoft in Redmond, some conferences in Russia, in Germany, and so on. So more or less, I talk at all of them about UI redressing. And you can also find me on Twitter. So this is how the table of contents looks like. We will begin with a typical introduction and end with a conclusion and outlook. Between, we will see at point 2 here, what's UI redressing, what's the public knowledge. This means which attacks are available on the desktop-based field. After that, I will show you which attacks can be ported to Android, which isn't really new research, but it's my research. And this is new, point 4, we will see some new browserless attacks. And depending on this point 4, depending on the new browserless attacks, I will show you some mitigation techniques against UI redressing, or rather tapjacking, which is the new thing here. So, introduction. I'm from Germany, as you can hear it from my accent. And for this reason, I have some historical knowledge about the German technology market. And as we can see here, there happened something in July 1999. Deutsche Telekom, the I think largest telecommunication company in Germany, who is offering internet connections, mobile devices, telephone connections, offered broadband connections here at this time. And this allowed us with DSL to serve a lot of faster. And due to this broadband connections, there disappeared a huge problem. And this huge problem were the premium number phone calls caused by dialers. So the dialer problem disappeared for more or less 10 years, as we can see it here. And at our new age, or rather since 2009, the dialers were again there because we have smartphones, we have telephones with computers inside of them. We can play mobile games on our smartphone, on our tablet, or other devices. And when we talk about attacks on mobile-based devices, we talk about, or usually we talk about Trojan horses, which means we are using our web browser as a victim to surf on the internet. We are clicking on a link or clicking on an element, and by doing this, we get infected by, for example, JavaScript code, which is executed at our browser. The other thing is, and this isn't actually an attack, is that we can install applications which have a lot of permissions. A good example is WhatsApp. WhatsApp can, for example, locate your network-based data. It can send SMS, it can send MMS, it can directly call phone numbers, it can read your contact data, it can manipulate your contact data. So, at least in my mind, it's an ideal spying tool for the NSA or other secret services. So, as I said, this is not an attack, it's just an application with many, many rights. And I think, is it really necessary that this application has these rights? Is it really necessary that this application is able to call a phone number? Especially, is it really necessary that this application is able to call a premium phone call number, which costs about €2 or €3 or $1 for 1 minute? And the question, the primary question of this talk is, can we as an attacker build an application which has no rights to do, for example, phone calls or read contact data? And or is it possible to do that? So we have an application like a calculator, which can nothing more than calculate, so mathematical things. And is this application able to call? Is this application to surf on the internet without having any rights? And this is possible, and I'll show you how. So let's begin with the public knowledge part. ULREDRESSING is a problem which is known since 2002. The background story behind that is that Jesse Ruderman, a security researcher from the United States, published in the Mozilla Bug Tracker that it is possible to make elements transparent, or rather to make iframe backgrounds transparent. And this ticket inside the bug tracker was closed by the Mozilla security team due to the reason that they said, it's more a feature than a bug. We want that things are invisible. We want that things are half transparent. It's nice to have, it's fancy. And this security problem from 2002 appeared again in 2008, and this problem was called clickjacking. Clickjacking consists of two words. The first word is clicking or click, and the second is hijacking. So we hijack clicks with clickjacking. And as we can see here, clickjacking is a part of ULREDRESSING. So ULREDRESSING is a set of attacks, and inside this set there are some other attacks, and one other set of attacks is called clickjacking. So wait a moment, I said clickjacking is an attack, and then I say clickjacking is a subset of attacks. We will see why in 1 or 2 minutes. So what we can also see here is that we have other attacks inside of clickjacking, which are called cursor jacking or file jacking, tab jacking, and so on. But let's see the attack from 2008. So a short video which was published at this year. Let's run. So we see here that we have a Flash application on a website which is guya.net, and the victim is going to this website and sees, I can get a high score if I click on buttons. And in this case, the victim is clicking a lot of buttons, and you can see that the score increases here. So a few moments later, we will see that the attacker, or rather guya.net, gets automatically access to the microphone or camera of a victim. So, and now with a half-transparent background, so the white background is half-transparent. in a few moments. So we can see that in the background there is loaded the Adobe Flash Player security settings web page, or rather in the past Macromedia, it's nowadays Adobe. And we can see that the clicks are allowing GUIA.net to get access to the microphone and to get access to the webcam. So here's the list of websites. GUIA.net will appear here in a few moments. Here is it. Yeah. And what we need now is that we have to select this element, and after that we have to click on Always Allow to have the automatically access. So, there it is. That's all, and after this we get the access. So this was fixed by Adobe, and this was called clickjacking at this time. Clickjacking is nowadays more than clicking on a button. And for this reason, clickjacking is called classic clickjacking. Yeah. And a classic clickjacking attack from today looks like that. We are a victim, are logged in on the Bing.com website. We can see it here. We have an account name, which is Marcus, so my name. We have on the right side a sign out link. And what we want is that the victim will click on this sign out link without getting noticed that he or she is clicking on it. So what we need is social engineering. Yeah, we have a headline here with funny pictures. We have two smileys and a button. And what the victim will think when he or she is visiting such a website is, hey, if I click on Click Me, I will see some pictures with maybe kittens and funny dogs and so on, and funny pictures. So I have to click on it. And by clicking on it, you will actually click on Sign Out. You can see here that we have an iframe element, which is loading Bing.com, and that we want to merge, or rather overlay the Sign Out link, which is in the iframe element, over the Click Me button. So we can see it here. We move it to the top left, so that the link in the iframe element is over our button, and here is the iframe transparent. So here half transparent, here completely transparent. So if I click on this button here, I will actually click on Logout. That's all. So when we have a look at UI redressing, or when we look at the set of attacks, we can see that we have the subset clickjacking, and that we have attacks like stroke jacking, drag and drop attacks, content extraction, event recycling, SVG maskings. And here is also a list with a lot of jackings. And this is a little bit difficult to explain in this short time, and thus I will show you two attacks. The first one is cursor jacking, and actually the easiest attack. So I have 4 links here. When I click on 2, so here, there appears an alert window with the value 2. If I click on 1, there appears an alert value with the value 1, and so on. So 1, 1, 4, 4, 2, 2, and 3, 3. I will click on 2, and look what happens. Click. I will click on 1. What? No. So I will click on 1, click, and nothing happens. So I will click on 4, click, and I will actually click on 3. So the magic behind this is this thing here. Our mouse cursor is nothing more than a picture, and in this case, the background of this picture isn't red, it's transparent. So you can see it here. I actually click with the top left of this element, so I click on 2, but I actually click on 1, so click, here it is. And once again, if I click here, click, there it is. Just to show it here, when I click here maybe, there is V2. So a little bit magic with CSS code. Another thing which is really cool is this is SVG maskings. It's a pure UI redressing attack, is that you can, and this is a Firefox feature only, mask elements inside of other elements like frames or iframes. And in this case, we can see that we have a logo here and a button. And what actually happens is that we are loading an iframe, which consists of the Ruhr University Bochum search engine, or which loads this search engine inside of Chrome. And in Firefox, with the same code, we have the search engine plus our masking. So if I click here and scroll a little bit, we can really see that we are inside of an iframe. Yeah. Okay, go a little bit up, and we can see that I can do searches, that the masking is there. So that's a part of clickjacking. There are some countermeasures. Yeah. I don't want to make it long. We have frame busters, so JavaScript code. We have HTTP headers like X-frame options, which protects you against clickjacking and some other attacks in Internet Explorer. We have the CSP, the content security policy, as a countermeasure, but it's not well implemented in newer browsers, so it's better to use X-frame options, or maybe both. And we have NoScript, which is the, I think, best security extension for browsers here available for Firefox from Giorgio Maroni. So we know now what UI redressing is, what clickjacking is, and for me at least, where arises the question, can we port the UI redressing attacks to mobile-based devices, or rather to Android devices? And when I have started with my research, which was in 2011, so 3 years ago, I saw that the market share situation is the following. We have here a small market share for Android, Symbian is there, and just a little bit of iOS. So here is the iOS part. And also here, a year later, we can see Android, or the market share of Android increased, and here, once again, Symbian, it decreased in this case, and iOS. When we have a look at 2012, we can see that Android has a market share, or had a market share of 66%, and in 2013, nearly 80%. So it's really worth to look at Android because, I mean, iOS has a market share of nearly 15%. That's nothing in comparison to Android. And when we look at versions which are in use, or at least which are in use in Germany, we can see that most of the people are using Android 2.x. The reason for this is that we have mobile phones in Germany which are, for example, Motorola Defi, and such a Motorola Defi device holds Android version like 2.1, and we can upgrade it to 2.2, which scares me a little bit, but this is the case in Germany and in most of the parts of Europe. Nevertheless, all of the attacks I will show you are working on all versions since 2.x. So also in the version 4.x and 3.x. Here are some screenshots. We can see that we have a notification bar on the top in both versions, so Android 2 and Android 4. On the top, the notification bar. Then we have a search engine with Google. We have our home screen, and we have some buttons here. So we can do a phone call, we can open the menu, we can surf. There are not so many differences between the versions here, at least if they are not customized. So the next step, by looking if the Android or the UI redressing attacks can be ported, is to have a look at the available browsers. And what we can see is that Firefox is available, so the Gecko engine. We have Chrome, so WebKit, or rather Blink at the moment. We have Opera with Presto in the past. Presto is also available on some TVs, But nowadays they switched, at least in the desktop-based field, to Blink, so the same as Opera or as Chrome. What we not have is Safari and Internet Explorer. But this isn't really important for us because there is just one attack which is working at Safari and just one attack which is working in Internet Explorer. So we can see here, for example, that 3 attacks can be easily be ported because the only thing what a browser needs in our case is that it supports frames or iframes, that it supports cascading style sheets, so CSS code, and JavaScript code. So this is possible in every browser. It's in every browser available. What we can see here, there are some attacks which are using some browser-specific features, like some attributes, WebKit directory, for example, in Chrome, which is necessary for file jacking, and tab jacking, which requires Firefox and so on. But all of these things are there. We have Chrome, we have Opera, and we have Firefox. Attacks which doesn't work is click checking because we doesn't have click events on Android devices. We can use our cursor, but these are actually touch events, not click events. We cannot do double click checking because it requires windows. We have rather tabs and not windows on mobile phones or tablet PCs. And cookie jacking because it's an Internet Explorer-based attack. Okay, new browserless attacks. When we look at Android, we can see it here in the emulator that we can do, for example, things like make the volume louder. Or here, I can do this. Or here. The crucial things are they are transparent, or they can be transparent with notification messages, as here. They disappear after a few seconds, so they disappear after 2 or 3 seconds. They can also disappear after 1 second. And I can click on them. So here, click, and we can see I actually clicked on the google.com search bar. So once again, these 3 things are very important. Click, I can click under it. So it's transparent for my actions. So the idea behind the new browserless attack is now the following. Isn't it possible to make such a notification message to full screen, to resize it? And isn't it possible to show it for a longer time than just 3 seconds? This is possible. And the result is the following. I will show it to you here, first of all. As I said, we have an application which has no rights to do anything, to do, for example, phone calls. So if where is it? Your applications, manage applications. Open, for example, the API demos. I can see that there are some permissions. So this application is allowed to read your personal information, to take pictures, and so on. So in this case, I will open the tab jacking application, which is, for example, my calculator. And we can see that it hasn't any rights. So no rights here. Just a calculator or just an application as a computer game, for example. So I open this application here. And we can see that there appears a window, which is actually the notification message, and a button. And I click on this button and look at the top left. What I did, I made a phone call. So the magic behind this is the following. I close it. You can see that I'm calling Mr. Fuber here. I ended the call. So now with a half transparent, or rather transparent background, not white, we can see that I have a button here, but I have the do not press words, and that I have an application in the background, and this application is the phone call application. So an application without any rights is able to open another application, is able to open the contact data, the phone call application, the web browser. When we count them, our application is able to open 16 other applications by using intent action in Android. So once again, we can see our phone call application in the background with a predefined number, and all I need is a click here, and we see that I am actually doing a phone call. So this is what happens. I have my notification, and I have my target application in the background. And by clicking on the notification, I will actually click under it because they are transparent for actions. So what can an attacker do? An attacker can manipulate contact data. It can use your browser to surf on web pages. It can close the browser in the background. It can lock your touch keysters, so we have a keylogger. It can do predefined phone calls. We saw that. And this was fixed by Google, and is the 0 day for today. It can install applications in the background with more permissions. So we can install an application with the help of an application which has no right, and this new application can, for example, do all of the things on your phone, like it is in the case of WhatsApp. Let me show that in a video. Oops, that's the wrong one. So this video is by Nico Schmidt, security researcher from Westfälische Hochschule, it is called in Germany. We can see it here that he opened the Android system settings to show that all updates were installed. After that, he's opening the target application here, and we see that the user should touch on this icon, and by touching on this icon, there appeared here something. I will show it to you again because it was very, very fast. So, just once again. Yeah, here's the version in a few seconds. So, with this touch keystroke, he shows there is no update available. When he opens the target application, and please look here at the notification bar, there will appear something by touching on this icon here. Here is an installed application in just 2 or 3 seconds. Yeah? So what actually happens is the following, now again with a transparent background. He shows here in this case that we can do, for example, notifications, or we can push some messages, send some messages, and so on. Now he removes it and opens the other application, which is there. And we can see here in a few moments that there appears the Google Play Market for a few moments, and that we touch gesture on this place here instead an application in the background. And once again, this application has no rights to do this. Yeah, it has actually 0 rights. So what we have learned is that we can use notification messages combined with social engineering to trick the user and to do a lot of things like phone calls, like installing applications, which was actually fixed by Google, but it's still possible as we can see it. And nevertheless, there appears the question, can I attack more than these 16 applications, which are available by using intent action in Android? And the answer is yes, of course, because we can click on the menu bar, as I can see it here. So for example, here, what I need in my game, in my application, my calculator, click on this point, for example, and then here, then for example here, and then e.g. here. Yeah? So what we need as an attacker are a lot of clicks from the victim on the right places, which is a little bit difficult, but it can be done with a lot of touch gestures. And if we have this touch gestures, we can, for example, and this is also possible with intent action, manipulate contact data with just 4 touch gestures. We can say that the victim is allowed to install applications which are not signed, which are not from the Android market, so which are, for example, from the attacker's application market. And we can wipe, or we can erase the mobile phone by, in minimum, only having 6 touch gestures, which is nearly nothing. Yeah. So we knew now that we can control, as an attacker, the whole mobile phone on. There is just one thing necessary, and this is our target application. This is our calculator, which has no rights. Yeah? And this cannot be detected by Google, just to say it. Well, there exists one countermeasure. Yeah? And this countermeasure is called filtered touches when obscured, which means if you are using this attribute or method for your button, this button will be block touch gestures which has layers over them, so which are, for example, not visible to the user. Yeah? And as we can see it here, this countermeasures are available since the version 2.2. So a Motorola Defi with 2.1 is completely, is definitely a victim in this case. Conclusion and outlook. So we know that most of the URI redressing attacks can be ported on Android devices. This is definitely no problem. Yeah. There were just 3 attacks in a set of 20 attacks, which don't work. We can use UI redressing on the desktop-based field and also on the mobile-based field, especially on Android. And the most important thing, at least for me, is that we are able, as an attacker, to install applications in the background, and that we are able to call premium number phone calls. So to get money with the help of a user. And last but not least, there are some countermeasures like extreme options, the content security policy, and this nice attribute available. But just to say it, this attribute isn't integrated in the native Android apps. So it isn't integrated in the phone call application or contact data application, which is a little bit strange from my perspective, but this is the case. Google doesn't integrate it. So that's all. Thank you for your attention, and if you have any questions, feel free to ask me. Questions? Good question. The thing is that iOS is asking for permissions to do, for example, push notifications. Yeah? And if you give such permissions, then it's possible. Otherwise, no. Okay. Yeah?
Can you use that filter when obscured on a web application?
Nope. Just on your own application, like for home banking or other stuff. So be aware if you download an application. It can be dangerous, even if it has no rights. Other questions? Yes? It was, can you speak a little bit louder, please?
So you need the notification needs for my app.
Yeah.
So that's why you mentioned the
Mm-hmm.
so if I don't answer, so my application will not be called.
This is right. But intent action can actually call just the 16 applications. But the user can open your application when by clicking on the menu. But it's a little bit difficult because the icons or the position of the icons can change. You know? But it's possible, you know, if you have enough touch gestures. Once again, please. Yeah. There were 3 applications in the past, and one application were in the Google market for over, I think, 4 months till it was deleted. It was my application. So the problem is that Google cannot detect it. Yeah? It can just look for some strings and for intent action, but as you maybe all know, is that we can use code obfuscation techniques, yeah, to hide these strings, to change them. And for this reason, Google isn't really able to detect it. There's just this countermeasure. And it isn't used in the native applications. So another one. Okay, otherwise after the talk. Then thank you very much for being here.